Hello everyone, welcome to my video on the derivative of trigonometric functions. So we already seen the derivative of sine and cos. We proved this in earlier videos that the derivative of sine is cos and the derivative of cos is negative sine. But we didn't see tan. So what's the derivative of tan? So the answer to that question is secant squared, and we're going to prove this. Okay, so the derivative of tan is secant squared. A couple of properties that we have to recall in order to prove this is 1 sine squared of x plus cos squared of x. This is a very famous property, you guys have to know this. It's equal to 1. And the second property you have to know, or recall from high school, you should have seen this, is that the reciprocal of cos is 1 over secant. And if you cross multiply, it's equivalent to saying that secant of x is equal to 1 over cos. You could think of this as over 1, this is over 1, and essentially you cross multiply. So these are equivalent. So keeping this in mind, let's go ahead and see the proof. So one way of doing this is looking at the limit definition, but an easier way to prove the derivative of tan is secant squared, this is our goal, is to invoke quotient rule. So we know that f of x is equal to tan of x. Well, we could rewrite tan of x. How do we rewrite tan of x? This could be represented as, this is another property, sine of x over cos of x. And we just transformed it into the division of two functions which we already know the derivative. So since we have a division, what should come to mind is quotient rule, and since we know the derivative of sine and cos, we should be able to solve this. So let's go ahead and do that. So we're going to apply quotient rule. So recall quotient rule. So I guess this is the third, or if this is the third, this would be the fourth property. So you just have to remember the rule is f divided by g if you have a division of two functions. This gives us the derivative of the top times the bottom minus, because it's quotient rule, the derivative of the bottom times the top. All that divided by the bottom squared. And this is what we're going to do now. So this means that f prime of x is equal to the derivative of the top. So I'm just going to write it this way. Sine of x in brackets prime times the bottom, cos of x. We just leave it, minus the derivative of the bottom, so cos of x prime times the top. Okay. And then all that over cos squared. Let's put the squared here. Cos squared of x. Okay. So we just applied this property here. We took the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Perfect. So let me erase this to give myself some room. Let's go ahead and actually write it out. So we know that the derivative of sine is cos. So we get here, this is cos times cos, so we get cos squared. Minus the derivative of cos, we know is negative sine. So here we have a minus times negative sine. That gives us plus sine squared, right? Two negatives make a positive. Sine times sine is sine squared. All this divided by cos squared. This is where we use the property cos squared plus sine squared, as was mentioned here. Sine squared plus cos squared is equal to 1. The order doesn't matter, it's an addition. So the numerator is just equal to 1. The denominator is still cos squared. And now lastly we have the reciprocal. So this whole thing, we could think of it technically, you could think of this as 1 squared and write it as 1 over cos all this squared. Properties of like your laws of exponents. You can think of both of these guys squared, so we put them in the bracket, 1 over cos of x squared. And we know that 1 over cos of x, which we wrote over here, can be rewritten as secant. Secant x, all that squared. And this is the property. This is what we want to show, that the derivative of tan is secant squared. So we showed that the derivative of tan is secant squared. Let's do the same idea to show what the derivative of cotangent is equal to. Okay, so let's do this together. Cotangent, we have to use our properties. We know that cotangent of x could be written as, one way of doing it is writing it as 1 over tan of x. And you could work with this. That would be one way of doing it. Another way would be cotangent could be written as cos of x over sine of x. My advice is, typically when I'm doing these types of problems, is I'm always trying to transform everything in terms of sine and cos. Those are the guys that I like to work with. If you want to work with tan, that's fine, but I would go with cos over sine. Okay. Another way, you could transform tan into sine over cos, and then since you're dividing fractions, you could flip it and you'll get back your cos over sine. So I'm going with this guy. Now I'm going to use quotient rule on this. We have a division, cos over sine. So this is going to be very similar to the argument that we saw with tan. So let's go ahead and do it. If you want, again, from this point, you should be able to do this on your own. So pause the video and try it. But let's go ahead and solve. So again, we're using the quotient rule. So we have f over g. When you have a division, it's equal to f prime times g minus g prime times f. This you have to have memorized. So the derivative of the top, I'm just going to write the answer. The derivative of cos is negative sine times the bottom times sine minus the derivative of the bottom, so the derivative of sine is cos, times the top, which is cos, over the bottom squared, sine squared. So this is what we have. So this is equal to, we have a negative, so we get negative sine squared minus cos squared of x, all that over sine squared, using a similar argument. Here, they're both negative, so the property doesn't hold. But if we factor out a negative, then we get sine squared plus cos squared. And that we know is equal to 1. So this is equal to negative sine squared plus cos squared in brackets over sine squared, which gives us negative 1 over sine squared. And the last property that we have to remember is that we could rewrite 1 over sine as, we could write it this way, negative 1 over sine of x, all that squared. And we could rewrite 1 over sine, this is one of the properties you have to remember, that this is equal to cosecant. 1 over sine is cosecant. So this gives us negative cosecant squared of x. And that's the derivative. Okay. So same concept, we used quotient rule. Some of our properties, 1 over sine equals cosecant, so that's squared, and we have our negative. Okay, let's keep going. Okay, so now we showed that the derivative of cotangent is equal to negative cosecant squared. Let's look for the derivative of secant. So same concept. If we know that the function is equal to secant, we saw earlier that secant could be written as 1 over cos of x. So we have a fraction. Using quotient rule now, because we have a fraction, this we could solve for the derivative. So f prime of x is equal to the derivative of the top. Let's use the prime notation. So 1 prime times the bottom minus the derivative of the bottom times the top, so times 1, over the bottom squared. So over cos squared of x. So the derivative of 1's a constant, so we know the rule. That's equal to 0. 0 times cos is just 0. So this is 0 minus the derivative of cos, we know it's negative sine, times 1 doesn't change it, over cos squared. Okay, so 0 minus negative sine, two negatives make a positive, so we get sine over cos squared. Okay. So this is the answer. Let's go ahead and get rid of the fraction. The way we could do this is rewriting this as sine of x over cos of x times 1 over cos of x. We could write it this way. So essentially what we did is we split the cos. So cos squared, we have two of them. Sine times 1 is just this. And the reason why we put it in this form is we're going to use our properties. So sine over cos, we know that's equal to tan. And 1 over cos, we know, is equal to secant. And we're done. So we know that the derivative of secant is secant tan. I know here I got tan first, but it doesn't matter. When you're multiplying, it doesn't matter the order. 2 times 3 is the same as 3 times 2. So I typically put secant first. So the derivative of secant is secant tan. Okay, and now the last one we're going to take a look at is cosecant. Okay, so now we're taking the derivative of cosecant. We have to remember our property. We could rewrite cosecant as 1 over sine x. And now we could apply quotient rule again. So same concept, so f prime of x equals, so I'm not going to write the rule because we've seen it already. So we're doing the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay. So as we saw earlier, the derivative of 1 is 0, so 0 times sine is gone, that's 0, minus the derivative of sine we know is cos, and cos times 1 is just cos, over sine squared. So 0 minus cos is just negative cos over sine squared. And again, so this is the answer. We're just going to rewrite it as a negative cos x over sine x times 1 over sine x. Okay, and using our properties, we have the negative from the front. Cos over sine is cotangent, and 1 over sine is cosecant. And this is our answer. So the derivative of cosecant is negative cosecant times cotangent. Okay, so all these properties here, these are your trig properties, these have to be memorized. Okay, so now that we've proved all the statements, let me show you a tip or a trick to memorize the derivatives. So one way of doing it on a test, if you have enough time, you could always reprove the statement if you forget, if you're nervous or for whatever reason. But a trick to memorize the derivatives is, first of all, we have sine cos, those just have to be known, tan cotangent, secant cosecant. So the first thing to notice is that whenever you have a cos, cot, cosecant, it starts with a c. Notice that your derivatives are going to be negative. And the ones that don't have a c are going to be positive. Okay, so that's the first observation you can make. And once you have sine, the derivative of sine is cos is easy. Derivative of cos, remember, because it starts with a c, we know our answer is going to be negative, so negative sine of x. Just keep that in mind. Once you know the derivative of tan, so again, this has to be memorized, derivative of tan is secant squared. Well, to remember the derivative of cotangent, now you know it because tan is secant squared, cotan is cosecant squared, and since it starts with a c, it's negative. Okay, so that's one way you can remember. Secant, the derivative of secant is secant tan, so once you have that one memorized, then you know cosecant, because it's the same idea. Secant, secant tan, cosecant, cosecant, cotangent. So it's like tan, it's like secant tan, but with a co in front. So the derivative of secant is secant tan, the derivative of cosecant is cosecant cotan. Since it starts with a c, again, it's negative. Okay, so this is, if you don't want to reprove it, let's say on a test, this is one way you could go ahead and memorize. Okay, so in this example here, it says to find f prime of x, where f of x is e to the x times tan of x. So let's go ahead and take the derivative. I'll let you pause the video and try this on your own. So if you got the answer is e to the x times secant squared x, this is wrong. Okay, so be very careful. We have a combination of two things that we've seen already. Trig functions and the fact that we have a multiplication. Okay, so we have to apply product rule. So if you caught that you have to use product rule, good job. If not, pay attention to the fact that there's a multiplication. That's super important. So in order to derive this function, we have to apply product rule. So f prime times g, so the multiplication, let's put the formula here, f times g. If you're multiplying two functions and you have to take the derivative, it's f prime times g plus g prime times f. Okay, so keep that in mind. So the derivative of this, if e to the x is our f, I shouldn't call it f, I should call it something else, the first function, and then this would be the second function. We're going to do the derivative of e to the x times tan of x plus, because it's product rule, we're using a plus, e to the x now we leave, and we multiply by the derivative of tan of x. Prime. So the derivative of e to the x is e to the x, tan stays, e to the x stays, and the derivative of tan is secant squared. Okay. We could go one step further because both terms have an e to the x, so we could factor that out. So let's go ahead and do that. If we factor out an e to the x, what we're left with is tan x plus secant squared x. Okay, and this is the final answer. So in this example here, we have f of x is equal to secant x divided by tan x. So let's go ahead and solve that. Again, pause the video, try it on your own. So we have a division, so we're using quotient rule. So let's put that on the board. Whenever you have a division, f prime times g minus g prime times f over g squared. So we're going to be using this. So let's go ahead and do that. Let's call this method 1. So f prime of x is equal to secant of x, prime times the derivative of the top times the bottom, we leave it, so minus the derivative of the bottom, so tan of x, all this prime, times the top, all this over the bottom squared. So let's go ahead and solve it. So the derivative of secant, you have to have your formulas memorized, is secant tan. Since there's another tan here, I'm just going to write tan squared, minus the derivative of tan is secant squared, and there's a secant here, so in all we have secant cubed, and on the bottom we have tan squared. So this is the derivative, but we could simplify this. So what we could do here is factor out a secant. There's a secant here and there's a secant cubed here, so we could factor out one secant on both sides. Let's do that. Secant x, leaving us with a tan squared minus a secant squared. All this over tan squared. Okay. Could we use the property? We have a property that's 1 plus tan squared equals secant squared. So if I subtract the secant squared on the left side and move the 1 over, what we get is tan squared x. I'm going to move the secant squared on the left side, so it becomes a minus secant squared x. And I'm going to move the 1 over on this side, becoming minus 1. Okay. So tan squared minus secant squared could be rewritten as negative 1. So this whole piece here, oops, is just negative 1. So this gives us negative secant on top over tan squared x. Okay. And this is the answer. We could probably simplify a bit more, but this is fine. Okay. Let's say you didn't see this method. You didn't want to use quotient rule. What you could do also, let's do method 2, is you could simplify. Let's go ahead and do that. So we'll call this method 2. So before you take the derivative, we could rewrite secant, and I would suggest to do this. I think my first instinct when I see problems like this is to always simplify it before just jumping into the problem. So secant could be rewritten as 1 over cos, and tan could be rewritten as sine over cos. Okay. One over cos divided by sine over cos. You have a fraction divided by a fraction, which means that you could multiply by the reciprocal. So the first fraction you leave, 1 over cos we leave. The division turns into a multiplication sign, and then you flip the second fraction. Okay, so this is multiplying by the reciprocal. So sine over cos becomes cos over sine. Okay. Notice that the coses cancel, and we're left with 1 over sine, which is cosecant. So this is equivalent to cosecant, and we know the derivative of cosecant. So f prime cosecant, so it starts with a c, so we know there's going to be a negative. And the derivative of secant is secant tan, so the derivative of cosecant is negative cosecant cotangent. Okay. And this is the answer, and this is equivalent to the other one. So let me just be a bit more precise and convincing. The answer that we got for method 1 was f prime of x was negative secant over tan squared. Yeah. So the solution we got for the derivative was negative secant over tan squared. We want to show that this is equivalent to negative cosecant times cotangent, so let's go ahead and do that. So secant could be rewritten as 1 over cos, and tan squared could be rewritten as sine squared over cos squared. Again, we have a fraction, we're dividing fractions, so we're going to multiply by the reciprocal. So the fraction on top we leave, negative 1 over cos, and the fraction on the bottom we flip, giving us cos squared over sine squared. Okay. So we have the negative in the front, we have a cos on the bottom, we have 2 coses on top, so one of them is going to cancel with the one on the bottom, leaving us with negative cos x over sine squared x. Okay. So we could rewrite this as negative cos over sine times, and then 1 over sine. So we have the negative in the front. Cos over sine is cotangent. And 1 over sine is cosecant. And this is equivalent to the answer we got for method 2. So they look different, but the answers are actually equivalent. Okay, so in this example over here, we have f of x equals ln of cos of sine of cotangent of x. So this is not a multiplication, this is a composition. So since we have compositions of functions, we're applying chain rule. So chain rule, you have to remember, it's f of g of x prime is equal to f prime of g of x times g prime of x. So essentially you take the derivative of the outermost function and then you work your way towards the innermost function. So starting with the outermost function, we have ln. So f prime of x, it's a derivative of, what's the derivative of ln? Well, we know the derivative of ln of x is 1 over x. Or think of it as the derivative of ln of whatever's in its bracket is 1 divided by whatever's in the bracket. So in this case here, it's going to be 1 divided by whatever's in the bracket of the ln, which is all this, cos of sine of cotangent. So we're just going to recopy that. Cos of sine of cotangent. 2, 3. Okay, so that piece is done. So we did the ln. Next step is the cos. So let's go ahead and take the derivative of cos. We know that the derivative of cos is negative sine. So we're going to have negative sine, but it's not of x, it's of whatever in the bracket. So now we did the cos, so we're dealing with just the sine and the cotangent. So negative sine of cotangent of x. Okay. So this piece here, the first piece was the ln, the second piece that we have here, this is a multiplication, so times negative sine of cotangent. The cotangent's done. The next piece that we have is the sine. Inside the sine we have a cotangent, so the derivative of sine is cos. But it's not cos of x, it's cos of whatever's in the bracket, which in this case is cotangent of x. Okay, so we finished with the sine. And lastly we have to take the derivative of cotangent. So times, I don't have room, so I'm just going to write it down here. So times, this is all multiplying each other. The derivative of cotangent, it starts with a c, so we know there's going to be a negative here. And the derivative of tangent is secant squared, so the derivative of cotangent is negative cosecant squared. Okay. And this is our answer. So we have two negatives here, they cancel each other, so we get a positive answer. And we could rewrite this as sine of cotangent times cos of cotangent times cosecant squared. All this over the bottom squared. Sorry, just the bottom, not squared. Cos sine cotangent. There you go. And this is the final answer. Okay. So this was an example of trig functions with a bit of chain rule. Let's keep going. So in this example here, we're asked to find the equation of a tangent line. They give us the function f of x equals tan of sine of x, and they want to know the equation of the tangent line at the value x equals pi. Okay, so at pi, what's the slope of the tangent? So let's go ahead and do that. First off, let's write down the formula. So the equation of a tangent line is the equation, I'm going to use t of a, it's f prime of a, x minus a plus f of a. Okay. So let's start off by going and find the slope. Okay. So the value a is essentially just pi. So even though it's written x equals pi, we know this is really the value of a. So we have the a here, we have to go find f of a, and we have to go find f prime of a. So let's begin by going and find f prime. So to get f prime, earlier in the semester we saw that we had to use the limit definition of a derivative, but now at this stage we don't have to use the limit definition of a derivative because we know product rule, quotient rule, and chain rule. So we can solve this using chain rule, because in this case we have a composition of function. If you're thinking of using the product rule here, this is wrong. This is not a product. It's not tan of x. So you really have to catch the difference of composition and product. It's not tan of x times sine of x, right? There's only one x here. It's tan of sine of x. The sine is inside the tan. Okay, so here with the product rule, here it's chain rule. The problem that we have here is chain rule. So to take the derivative of tan of sine of x, we're going to start off with tan. The derivative of the outermost function is secant squared, not of x, but of whatever's inside the brackets of sine x, multiplied by, on the outside with the derivative of sine, it's cos. Okay, so we found the derivative. Next, what we have to do is find the derivative at the point A, specifically at the point pi. So let's go find, this is in, what we're really finding is the slope. So we're looking for f prime of A, which in our case is f prime of pi. So we're plugging pi into this over here. So we have secant squared sine of pi times cos of pi. So especially if you don't have a calculator, you have to have your unit circle memorized, because you have to figure out what sine of pi is and cos of pi is. So secant squared sine of pi, this is our unit circle. We have the x-axis, the y-axis. These are all ones. 1, negative 1, negative 1, 1. Every point is cos sine. So you read for cos on the x-axis and for sine on the y-axis. So if we're going by pi, it's customary to start on this axis here, on the x-axis. This is your 0. And then we move counterclockwise. So we're going upwards. Moving 90 degrees is pi over 2. Moving 180 degrees over here, this is the distance of pi. And then this is 3 pi over 2. 270 degrees, 3 pi over 2. 360 degrees, you're back at 2 pi or at 0. Okay, so cos of 0 is equal to cos of 2 pi. In this case, all we really care about is this point here. Thinking of it as a coordinate point, it's the point on the x-axis negative 1, on the y-axis 0. So the x, we're looking at cos, and the y, we're looking at sine. So sine of pi, we're looking at the y, is 0. And then for cos of pi, you're looking at the x-axis. So we're looking at the value of negative 1. So cos of pi, using the unit circle, is negative 1. Okay, so make sure you have your unit circle memorized. There's the main 16 points. Those for sure you have to know. So now we have secant squared of 0 times negative 1. So this gives us negative 1 times, I'm just going to move the negative 1 in the front, secant squared of 0. So secant is not on the unit circle. So how do we deal with this? Well, secant could be rewritten using our properties as 1 over cos of 0, all this squared. Okay. And cos of 0, now we could use our unit circle. This is why it's always a good idea to rewrite everything, all the trig functions that are given to you in terms of sine and cos, because we could always refer back to our unit circle. So cos of 0 for over here, now we're looking at this point here. This is the point 1, 0. So cos of 0, you're looking at the x-axis, is 1. So this here is equal to 1. 1 divided by 1 is 1. 1 squared is 1. And then 1 times negative 1 is negative 1. So the slope of the tangent line is negative 1. So if the question was asking to find the slope of the line, we're done. In this case, it's asking for the equation of the line. So we just found this value here. We have to go find the rest. Okay. So we have the slope. This is done. We have the value a. A is pi. The only thing that we have left to go get is f of a. And f of a is just the original function evaluated at pi. So let me just squeeze it up here. So the original function is f of x equals tan of sine of x. But since we want to evaluate it at pi, we're doing tan of sine of pi. So let me keep the unit circle. Again, we're using the unit circle with sine of pi. Sine of pi we saw is, we're looking at the y-axis, is 0. So this is equal to tan of 0. tan of 0, if you know the function of tan, you know what the answer is here. It's 0. But if you didn't know that, what you could do is, let me just give myself a bit of room, is rewrite tan in terms of sine and cos. So tan could be rewritten as sine over cos of 0. And now we could refer back to our unit circle. So sine of 0 is 0 and cos of 0 is 1. So this is 0 over 1, which is just 0. Okay. So if you knew tan of 0 is 0, then that's fine. If not, you could get it using the unit circle. Okay, so now let's write the equation of the tangent line. So the final answer, let me just erase this to give myself some room. So the equation of the tangent line, f prime of a, the slope we got was -1. X we leave, minus a, which in this case is pi, and then the f of a was 0 plus 0. So the equation of the tangent line is -x plus pi. And we're done.